This is section 1.6, part B. We saw some patterns with how our graphs shift based on what the equation of the quadratic function does, and we'll now look at some examples of that. I would like to use the idea of transformations to graph the function f of x equals x minus 4 squared minus 3. Because of the square, I know it's going to be a parabola. Compared to my original parent function, the parabola with vertex at 0, 0, this one has been moved to the right 3, and to the right 4, and down 3. So those are the two transformations that I'm going to want to draw. We're also being asked to use find the vertex, zeros, x and y intercepts. So let's start working on that. I'm just going to pop down to my graph for a moment and say if I've gone to the right 4 and down 3, my new vertex over 4 and down 3 is right there. So the new vertex is certainly going to be 4, negative 3. We'll fill that in right away. All right, let's go ahead and start working on the intercepts before we do anything else. For the x-intercepts, we always plug in y equals 0. In this case, y is really the f of x, so I'm setting f of x equal to 0. And again, because of the square here, the easiest way for me to solve this equation is using a square root method. I'm going to add the 3 to bring it over to the left-hand side. And then I'll just take the square root on both sides. I have to make sure to include both the positive and negative square roots. And then on the right-hand side, I've got some inverses going on here. The square root and the square do and undo, so I can get rid of those. And then adding the 4 over, I'm going to put it out in front. 4 plus or minus the square root of 3 is equal to x. So there are my x-intercepts. Well, actually, those are the zeros, but when I put them into the point form, they'll be the x-intercepts. In order to graph those, it's going to be really helpful to me to have decimal approximations. If I don't do that, it's going to be really hard for me to figure out where to put those on the graph. So I'm just going to grab my calculator and do 4 plus the square root of 3, and then also 4 minus the square root of 3. So my x-intercepts, or my zeros, are approximately 5.73 and 2.27. Sorry about the dogs barking there. I think I got them quieted down. So again, 5.73 and 2.27 were our x-intercepts. So let's put those on our graph. 5.73 around there, and 2.27 around there. That's actually enough. I've got my vertex and 2 additional points. I could make a pretty good sketch of the graph right now, just drawing in that U shape or that parabola shape. But we were asked to find the y-intercepts as well. So let's get that in before we do our graph. For the y-intercept, we plug in x equals 0. So back to my original function, I would get, it's really f of 0, isn't it? Might as well put that in there. I would get 0 minus 4 squared minus 3. Negative 4 squared is 16 minus 3 would be 13. So on my picture down here, I'm just going to add a little bit of extra space. About 11, 12, 13 would be around there. So when I go to draw my graph, this goes up really fast. It doesn't even hit the y-axis till we get all the way up here to 13. The other side will go up similarly, like so. All right, let's start filling in our chart here. We already identified the vertex right here at 4, -3. The axis of symmetry, this vertical line right here, is the mirror line. The graph is symmetric on the two sides of that vertical axis. And notice that's the line right through the vertex. It's the line x equals 4. That's no coincidence. The axis of symmetry will always go through the vertex. So its equation is always going to be x equals whatever that x value was at the vertex. Domain, all real numbers, or minus infinity to infinity. And the range, it looks like the smallest y value on this graph would be right here at the vertex. So the smallest y value is -3. And then the y's go up forever, so up to infinity. I will use a bracket on the -3. That -3 is included, right? The graph actually hits that y value of -3. All right, the zeros. We found the zeros right up here. I'm going to go ahead and write them down as the exact values. X was 4 plus or minus the square root of 3. And then the x-intercepts. If I write these as points, maybe I'll use the decimal approximations this time. 5.730 and 2.270 would be my x-intercepts. Again, that was just a choice that I chose to use the exact value here and the decimal approximations there. When you're doing homework in my math lab and so on, they always tell you what they want, so just read carefully. Finally, the y-intercept was up here at 13, so x equals 0, y equals 13. And there's the information in the graph for that function. All right, let's do one more example together. This time my function is -1/2 times x plus 3 squared. Once again, because of the square, I know the graph's going to be a parabola. In terms of the transformations, I have a negative multiplier, which means we are going to have a graph that's reflected across the x-axis, or upside down. The multiplier of 1/2, because that's smaller than 1, this parabola is going to be a little bit wider than the parent function. And then finally that x plus 3, the plus 3 inside the parentheses, will shift to the left 3. So for right now, let's just see if we can plot the vertex. The only thing that changed our vertex was this left 3. So from the origin, if I go left 3, I will be right there. And my vertex is at the point -3, 0. All right, next I'm going to work on my intercepts. So let's start with the x-intercepts. Putting y equal to 0. I'm going to start by dividing both sides by that -1/2. But of course 0 divided by -1/2 is still 0. And then to get rid of the square, once again I'm going to use the square root method, so I'll square root both sides. putting a plus or minus on the left. But the square root of 0 is still 0, and positive or negative 0 is still 0. So this whole left side is just 0 this time. On the right side, once again, the square root gets rid of the square. Those are inverses. And I have 0 equals x plus 3. Subtracting the 3 gives me x equals negative 3. Now I'm going to point out that's not exactly a surprise. The x-intercept is right at the vertex this time. So it's good to have it confirmed, but we probably already knew that was coming. All right, let's do the y-intercept. Putting in x equals 0. And so I will get negative 1/2 times 0 plus 3 squared, or negative 1/2 times 9 is negative 9/2, or negative 4.5. So my y-intercept down here is at negative 4.5. All right, so we've done all of our intercepts, but we actually don't really quite have enough information to draw a good graph yet. Remember I said that in addition to the vertex, we always like to have 2 additional points. And this time I only have 1. What I'm going to do is I'm going to use the symmetry of the function to figure out another point. Starting from the vertex, notice that when we went over 3 to the right, the y value was negative 4.5. By symmetry, if I move 1, 2, 3 to the left, I should still have that same y value of negative 4.5. So these 2 points are symmetric points, and that's going to give me enough points that I can more accurately draw my parabola. So here we go. We knew it was upside down or reflected across the x-axis. We're seeing that right now. And as far as it being a little wider than the parent function, you may be able to see it visually, but the fact that we got the extra points really took care of that for us. So there's my parabola. All right, my axis of symmetry goes through the vertex here. And that has an x value of 3, so x equals 3 is that vertical line that forms the axis of symmetry. The domain, always for quadratic functions, is all real numbers from negative infinity to infinity. The range. The smallest y values actually go all the way down to negative infinity. But the largest y value is 0. It does include the 0, therefore I put a bracket. The zeros of the function, there is only one. That was this x equals negative 3 right here. And if I write that as the point, negative 3, 0, it becomes my x-intercept. The y-intercept was at 0, negative 4.5. All right, so that concludes part B of section 1.6.